Welcome back to Applied Mathematics. In this video, we're going to be looking at some volume applications. Right? Let's jump right into an example here. Consider the swimming pool depicted below. If it is being filled by two hoses which can each transport 0.750 cubic feet per minute of water, how long will it take to fill the pool? The first thing I want to look at here is, how do I know that this is a volume application? I mean, sure, the title of the video is right there. It says I'm going to be using volume. But what am I looking at to solve this problem? Well, specifically, the first thing I see is this measurement here, 0.750 cubic feet per minute. If I have a measurement in minutes, I can use this rate to convert it, if I have a measurement in cubic feet, I can use this rate to convert it to a measurement in minutes. I'm asked how long, so I know that minutes is what I want at the end, which means that cubic feet is what I want at the beginning. So, area in cubic feet. And then 1 minute is 0.750 cubic feet, although that's actually not true because there are two hoses. So 1 minute is 2 times 0.750 cubic feet. But that's okay, that's the idea. And when we have the area in cubic feet and we multiply by this unit rate, it's going to give us a time in minutes, which will answer the question. Now, all that leaves is figuring out the area of this shape, which is definitely a bit of an irregular polyhedron. Right? Everything is flat sides. This side is notably slanted, but the other sides really look like they're going to form some straight angles. And so we can actually use that to our advantage, right? In general, the area of a shape where it has the same walls on two sides and some space between is, what am I doing? The volume of such a shape is the area of the base times the height. I keep hitting the wrong button. Sorry about that. All right, so what am I looking at here? Well, I'm looking at the base being this front face, and then the base being that back face, right? So from the front face to the back face, we're just taking this trapezoid and dragging it along and reproducing it. So the distance between the two trapezoids, it is very difficult to do this kind of gesturing in 3 dimensions. I probably look like a crazy person, that's okay. But the distance between these two trapezoids is the measurement over here, 40 feet. And then I know that the trapezoids themselves, I can calculate their area. So if I hit the right button and I draw just the trapezoid, that is the front face of this thing, I know I've got 8.75 feet here, I know I've got 3.50 feet here, and I've got 64.0 feet here. Well, the area is going to be the perpendicular distance. I'm generally going to assume that the walls of the pool are all vertical and it's only the bottom that's slanted, which means that the angle between the water level and the walls are right angles. Those are parallel lines. So we can take 1/2 of 8.75 plus 3.50 and multiply that times 64.0. I'll just plug all of that into a calculator at once. I've got 3 sig figs out here, so I'll keep that. This comes out at 392. And the units there would be square feet. All right, so that's my area. And then my height, as I said before, is this 40 feet. So the volume is 392 square feet times 40 feet, which comes out as 15,000 in change. I've only got 3 significant figures, so I will round that and call it 15,700 cubic feet. All right, there's my volume. But the reason that I wrote out that list at the beginning was to remind myself that the volume is not the end of the story. The time is what I want. And to find the time, I'm going to have to take the 15,700 cubic feet and multiply it by 1 minute over 2 times 0.750 cubic feet. When I do that, the cubic feet will cancel each other out. The minutes will be left. That's the units of measure that I want. So I take my 15,700. I divide by 2. I make a mess of everything. I divide by 0.75. And my calculator tells me that this is going to come out at 10,500 minutes, right? 10,466.67, but 3 significant digits, 10,500. All right, that's a lot. It's going to take a while, but I think that makes sense. As swimming pools go, this was a relatively large pool. All right, certainly not Olympic size, but relatively large for a backyard pool. And multiple days is kind of my expectation of filling a backyard pool with a garden hose. So 10,500 minutes, I guess I could divide that by 60 to get that that's 174 hours, and divide that by 24, and it's going to be 7 days. It'll take about a week to fill the pool up. Yeah, that seems fair to me. All right. Let's move onward. My personal favorite application of volume is density. In physics, we say that density is mass divided by volume. But in mathematics courses, we tend to use the US customary system, and the US customary system of mass is never ever used. So we'll go with a weight density. Density is weight divided by volume. So let's say you plan to cast a cylinder measuring 3.50 inches in diameter and 5.25 inches tall out of a resin foam which has a density of 0.450 ounces per cubic inch. We want to calculate the weight of the cast object. Very similar to the last problem, the first thing that I notice here is that we have this units of ounces per cubic inch. We are asked for a weight. A weight is given in ounces. So to get that, I'm going to want to multiply this thing times a volume in cubic inches. All right, well, it's a cylinder. Cylinders are very straightforward. The volume is going to be pi r squared h. We are given a diameter, not a radius, but that's easy enough to figure out. Half of 3.50 is 1.75. And then the height was 5.25. And throwing all of that at my calculator, I get 50.5 cubic inches, rounding that to 3 significant digits. Then from there, if I take my 50.5 cubic inches and I multiply by 0.450 ounces per cubic inch, well, then the cubic inches are going to cancel out. I'll be left with ounces, which is exactly what I want. So 50.5 times 0.450 My calculator tells me comes out at 22.7 ounces. All right, not a lot else to talk about on that. The biggest challenge on working with these sorts of applications is, first of all, recognizing that there's probably a unit rate somewhere in the statement of the problem. And second of all, recognizing that you have a relatively simple shape, or if you don't, then you can still figure it out. Right. In any event, I don't have anything else to say on this subject right now, so I'll wrap up the video with that. As always, thanks for watching, and I'll see you next time.